Hi, welcome to SS 8.3, volume of right prisms and cylinders. So a right prism is basically any shape. It could be a triangle, it could be a square, whatever, and it's connected by rectangles to the same shape at the top. Sorry, my drawing is terrible. Okay, so a cube or a Toblerone bar or something like that. One of the misconceptions that I often see with students is that they get this word mixed up with pyramid. So pyramids are the pointy things. So it might have a square base, and then it goes up to a point at the top. It might have a round base like an ice cream cone, or it might have a triangular base and go up to the top. So there's a difference between a pyramid and a prism. Prisms do not have pointy tops. Prisms are the same on the top as they are on the bottom. Okay, and they are always connected by rectangles. All right, let's get started. The first thing you need to know is a good review of area. These are formulas that you really should have memorized if you're going to do any further calculations. You need to know your basics of area. So for a rectangle, it's just length times width, or base times height, same thing. If a parallelogram, if we were to cut off this chunk here and glue it on over here, you would just have a rectangle again. So we just do the vertical height times the base. Let's go over to the triangle, and we do 1/2 the base times height. Another way to write that is BH over 2. A circle is pi r squared, and you need to remember that radius is a distance from the center to the outside of the circle. All the way across would be considered a diameter, and so there is a difference between radius and diameter. You should hopefully know that already. And one of the hints in the middle here says always use the perpendicular height, especially for trapezoids and parallelograms. The trapezoid at the bottom, basically if we were to take off this chunk and put it over here, it's the same distance. So they're taking an average of A and B, add A and B together and take the average of that, multiply by the vertical height. And the reason it's got divided by 2 here is because that's how you find average, A plus B over 2. Okay, just a quick review about the difference between volume and capacity. They're really similar, and I think there's a lot of websites and even some teachers that kind of use these two words interchangeably. They're very, very similar. Volume is more about how much space an object takes up. And so each one of these 3D objects at the bottom takes up a certain amount of space, and we could find the area of the base of that object multiplied by the height to figure out how much space it takes up. It's usually measured in cubic units, so centimeters cubed, because it's a 3D object, right? Or meters cubed. Okay. Usually it follows some type of formula like length times width times height. Capacity is a little bit different, a little more difficult to measure too. Capacity is just how much does your container hold. So for example, if you have a cup, capacity is usually used for liquid, but there's no reason why you can't pour macaroni in your cup or popcorn or whatever, or dirt. So it's not always a measure of liquid, but that's commonly what it's used for. It's usually measured in cubic centimeters, milliliters. You can see there's gallons, quarts, pints, cups, liters, milliliters, all those guys. Not every object has a capacity, right? If you were going to say how much does this orange block hold? Well, nothing, because it's a solid orange block. It takes up space, it has a volume, but it doesn't have a capacity. It doesn't have the ability to hold macaroni. Okay, our basic shapes here, remember this is a prism. and prisms are the same on the top as they are on the bottom. And technically what we're doing is we're going to find the area of the base, and then we're going to multiply it by the height. So we're going to find this purple area, and then we're going to multiply it by the height. And we know that area of a rectangle, that purple base, would just be length times width, and then times the height would give us our volume. If it was a cylinder at the bottom there, pi r squared is how you find your area of the circle. And so imagine finding the area of that circular base. How much space does that take up? And then multiply by your height. Okay, on this slide I just want to show you the best way to organize your question if you're doing volume. So let's say, for example, we've got that shape that we had on the front. Okay, and maybe they've given you this face, and maybe they've given you the length. So let's say that we have measurements of 3, 2, and 4. We'll call these meters. Okay, so the first thing you want to do is write your formula. V equals L times W times H, length times width times height. Then you want to plug in those numbers. So underneath your V, you want to continue with that same pattern. Line up your V, line up your equal sign, plug in the numbers for length and width and height. And in this case, it doesn't matter which one goes where, because multiplication has that commutative property where it doesn't matter what order it's in. So we'll say that the length is 4, the width is 3, and the height is 2. So we've plugged all those in, then we continue with our pattern, bring down our V, bring down our equal sign, solve our problem. 4 times 3 is 12, times 2 is 24, and put in your meters, and there are 3 dimensions, 1, 2, and 3, so it is meters cubed. So this is a great way to organize. You want to keep all your volumes lined up, all your equal signs lined up, and just keep dropping down solving parts of the equation. Quite often I'll see students go, volume is length times width times height, or maybe they even forget to put down the equation. This is your recipe, gotta have it. And then they'll go, volume is 4 times 3 times 2 equals 24, or something like that. You can't have 2 equal signs in an equation, so it's better to keep it all organized and drop it down and put it straight underneath. Alright, if you live in Saskatchewan, you should know how to find the volume of your bin. So a bin is just like a soup can. It is just a cylinder, and it has a cement base inside here. And the first thing that will happen if you're filling up your bin is that cement floor will get covered in grain. So we need to know the area of the base. In this case, our base is a circle, and so area of a circle is pi r squared. Okay. Later, when we find the rest of this, we will determine the height of the whole bin and multiply our area of the base times the height. That will give us our volume. So for now, let's just figure out the area. The measurements that I've given down here, area equals pi times radius is 18 squared. I'll just grab a calculator here, and 18 squared is 324, so pi times 324. We have A equals 1017.36. So that's just how much grain is covering, these are feet, I guess, square feet right now. That's how much grain is covering the floor of the bin. Then I want to take that measurement and multiply times the height, which is 18. Okay, because volume is the area of the base times the height. So if I multiply by 18, that gives me 18,312.48, and we, oops, I can't erase cubic feet. So I just about made that very common mistake of forgetting that area is measured in square feet and volume is measured in cubic feet. All right, I hope your bin is filled right to the top.